Hello and welcome to this afternoon's webinar, Human-Centric AI and its Applications. My name is William O'Gorman and I am the Artificial Intelligence Innovation Hub Officer here at Haaga-Helia University of Applied Sciences, Helsinki, Finland, which is one of 6 innovation hubs as part of the Ulysses European University. Today's webinar will include 4 presentations from experts in the field of AI and its relation to human-centric applications. Each presentation will take about 15 minutes, and there will be a short time for questions after each presentation. We will also have some time at the end of the event if you have some extra questions for our presenters. You can post your questions via YouTube, and we will do our best to answer them. Before I proceed, I'd just like to give a little introduction to Ulysses and the AI Innovation Hub in Haaga-Helia. So here we have Human-Centric AI and its Applications by Haaga-Helia University of Applied Sciences. This roundtable is part of the calendar of activities of Compass, which is leading Ulysses to become a European University of Excellence through research and innovation. This is a Horizon 2020 project of Ulysses and the flagship for its research and innovation agenda and strategy. Ulysses European University is a connection of 6 innovation hubs, which are tackling 6 research and innovation challenges around Europe, forming one innovation ecosystem. These innovation hubs are placed in Finland, where we have the AI Innovation Hub, in Košice, Slovakia, which is dealing with digitalization. In Innsbruck, in Austria, we have biotech and circular economy. In Genoa, we have tourism, art and heritage. In University Côte d'Azur in France, we have aging and well-being. And finally, in Sevilla, in Spain, we have energy, transport, and smart cities. The innovation hubs are the innovative joint structures for collaboration within the Ulysses community. Haaga-Helia's role as an innovation hub relates to artificial intelligence. And as we are aware, AI is becoming more and more prevalent in our daily lives. And with this Innovation Hub, we aim to find solutions related to AI, train businesses related to AI, and identify ways to learn about the increased role of AI in our everyday lives. Today, we're lucky to have 4 expert presenters who are going to talk to you on a range of topics related to AI. I would like to welcome, we have Professor Stefan Schlögl from MCI, the Entrepreneurial School in Austria. He will be talking about interacting with unsocial machines. We have Thomas Varanka, PhD researcher at the University of Oulu in Finland, with his topic, How Machines Recognize Human Emotion. Himanshu Sani, who is an AI machine learning business development lead for Amazon Web Services, and his topic will be improving student outcomes and enabling rapid modernization. And finally, we have our own Heli Kortesalmi, a senior lecturer here at Haaga-Helia University of Applied Sciences. And her topic will be applying AI and RPA solutions in small companies accounting. But to begin, I'd like to pass the floor over to Stefan Schlögl from MCI in Innsbruck. Go for it, Stefan. Thank you.
Thank you, William. Can you give me the right to share my screen?
Okay.
Thank you. Go just a second. So now you should all be able to see my screen. Yeah, thank you so much for your introduction, William. My name is Stefan Schlögl. I'm a professor of human-centered computing at MCI, the Entrepreneurial School in Innsbruck. And I would like to spend the next 15 minutes or so to talk about a rather provocative topic about interacting with unsocial machines. This is a topic that I have been working in for the last more or less 10 years, ever since I started my PhD in computer science and human-computer interaction, looking at how people interact with technologies and specifically with artificial intelligence technologies. And inside artificial intelligence, my focus was on speech-based interaction, on dialogue systems like Alexa, Siri, Cortana. That's why I called it Alexa, Siri, Cortana et al. Interacting with all these unsocial machines. This whole topic of talking or interacting with machines through human language started actually all the way back in the 1950s. In 1950, when the grandfather of artificial intelligence, Alan Turing, presented his Turing test, and many of the students and many of the researchers know about the famous Turing test, where basically the idea is that I build a machine that is so convincing that I, as a human, do not know anymore whether I'm interacting with a machine or with a person. We have every year competitions, Turing test competitions, that try to do exactly this. Simulate human behavior based on natural language, on human natural language, mainly chat-based, so text-based, but more and more also spoken, in order to, well, basically to a certain extent, you could argue, in order to trick people into believing that they are dealing with an actual human being. Now, whether this is a good thing or not, I leave this up to you. I find it fascinating that for the last 70 years, we have actually tried to build machines that do something that we are doing best, communicating. It's from an AI point of view, a very challenging topic. Researchers all around the world have tried to approach this. One of the first researchers that actually built a machine that passed, to a certain extent at least, the so-called Turing test was Joseph Weizenbaum. In 1966 at MIT, he basically built out of fun a small text-based program that was simulating Rogerian psychotherapist. So basically somebody who would listen to you talk to help you, deal with problems that you might have. And the funny thing about this, the very surprising thing about this, also for Joseph Weizenbaum, was that actually people started connecting with this tool. Although they were aware that Eliza was not really a human being, was not really an intelligent thing, rather it was a computer program. But still, they sort of got attached to this. So there was a binding, like on an emotional level, generated between a computer, between a machine and the human being. And that was quite surprising, as nobody really expected that. Not even Joseph Weizenbaum himself actually expected for this to happen. With this first sort of success in building intelligent, more or less intelligent machines, researchers thought that it would take no time to actually build real artificial intelligence. But history has taught us a different story. It took quite a long time, actually, to build something that is or was really convincing and would, to a certain extent, really simulate human spoken capabilities. And the first company to actually produce that was Apple. Well, actually, they didn't really produce it. Apple was quite clever. They bought a startup in the early 2000s, around 2007-ish, 2008-ish. They bought a startup that came out of DARPA that was focusing on building in sort of a universal artificial intelligence based on speech. The startup was called Siri. And before Siri would be available on many different platforms, including BlackBerry and Android and so on, actually Apple bought them and made it an integrated thing of iOS. So in 2011, Apple Incorporated announced his Siri intelligent agent, a thing that you could talk to that would mimic human natural language behavior, that would understand pretty much everything that you would say. That would be your very personal digital assistant. You wouldn't even be able to sort of differentiate it anymore from a human being. It was a big thing. At the time in 2011, I was in the middle of my PhD, and we were building dialogue systems. We were building these kind of spoken interaction systems. And we knew how difficult it actually is to build something that would understand human language. So we were quite surprised that Apple brought out this very new tool in their keynote. And for us, it was really interesting to see how actually people would use that. And that was a big step that Apple took at the time. It's not so much that they were clever enough to buy a company, a startup that offered a certain technology, but no, they basically put this technology inside the iPhone and therefore in the hand of millions of people. And those of you who know a bit about artificial intelligence know that AI technology depends very much on data. And so if I want AI technology to improve, to get better, I need people to use it. The more they use it, the better it gets. And that's what Apple actually did. They took speech recognition, speech understanding out of university labs and put it into the hands of millions of people through their Siri assistant. Another thing happened around this time, which I didn't quite understand in 2011, 2010, 2011. Another company started hiring all kinds of computer linguists. So people that study human language and try to basically build human language models through computers. This other company was Amazon. And 3 years later, I finally understood why Amazon did that, why Amazon started to hire out of universities PhD students that did their PhD in computational linguistics. They built their very own digital assistant, Amazon Echo. And most of you probably know Amazon Echo. Many of you might actually have an Amazon Echo at home. Alexa, talk to Alexa. We have somebody from Amazon speaking later, but the goal of Amazon is pretty clear. They want to sell products through this. It's not that they want to build a digital assistant. They want to build a digital assistant that helps you buy stuff. That's the whole purpose. And to make this, to support buying behavior, to make purchasing things as easy as possible, as natural as possible. And what is more natural than human language? From a research point of view, however, it's interesting how people started interacting with these things. While at the beginning, they were quite stunned how clever those things seem to be, Alexa as well as Siri, the money and effort that went into building very convincing spoken output, the effort that went into building speech synthesis that has a specific tone, that has a tone of voice that is sympathetic, that is emotional, was really amazing. And that's why those tools, they sound that well. And also the recognition engines that I use that are quite not that bad. However, there was an article in 2018 in an Austrian newspaper. Sorry, it's in German, but essentially it says, Alexa, you're stupid. And that's what they are. Those things are super stupid. And I hope that, the following speaker from Amazon does not really, isn't annoyed when I say that. Alexa is not clever at all. What it does is essentially some keyword spotting, some sophisticated co-occurrence analysis, which words occur with which other words, and tries from this voice input, tries to identify an intent, something that a user wants to do, buy a product. To do this, I might actually give you a bit more background on computational linguistics and computer language. Well, what's the problem here? Well, the problem is, if you think about computer language, so how computers understand things, computers are formal entities. They use formal languages, programming languages. These formal languages are highly and very precisely defined. So code like print, bracket 2 + 2, bracket closed, is a legal program in Python. Whereas if you move around the brackets a little bit, although you use the same letters, the same numbers, the same linguistic elements, it's not understood anymore. So computers need a very formalized way of interpreting data, essentially. And this formalized way of interpreting data has very specific rules, semantics, meaning, and so on. So 2 + 2 is 4, and 1 divided by 0 is not possible. And we have to comply with these rules. Computers have to comply with these rules to understand what we actually mean. Now, if we look at human language, that's actually not that easy. We are part of Ulysses with 6 different countries, 6 different languages, natural languages, and we all know the difficulty of making oneself heard in a different language, the difficulty of speaking in English, Spanish, French, Slovak. And we also know that our human language, as beautiful as it is, has a lot of ambiguities. Things that sound the same, but might mean something different. He saw her duck. It could be the animal, the duck, or somebody ducks. Also, we can express things in different ways. Not to be invited is sad versus to be not invited is sad. Okay, computers have a really hard time to understand these similar expressions that are expressed in different ways. And that sort of I try to demonstrate how difficult it actually is for a computer program to understand human language. How does this work? Well, essentially, a dialogue system like Alexa or Siri is composed of 5 different parts. Part number 1 is something that turns spoken input, sound, into text. Call this speech recognition. Then there's some component that tries to analyze this text and make sense of this text. That's natural language understanding. And then we have something that controls this whole dialogue, which is the dialogue manager. Out of this control comes an intent, and this intent generates text output, natural language generation, and this text output is then vocalized into speech. That's text-to-speech synthesis. And all these different components, they have entire research fields behind them. So and groups all around the world work on only one of these fields to optimize them. And companies like Apple and Amazon and IBM and Microsoft, they have loads of resources to actually pour into these components to make these systems more and more convincing. Now, one really tricky thing, and that relates back to the title of my talk today, Interact with Unsocial Machines, is we realize that actually those assistants are utilitarian. Basically, they achieve a certain purpose, but what they are not is intelligent. They are not socially intelligent. They don't have empathy. And so there was another article in an Austrian newspaper that basically says, well, we need KI, we need AI, artificial intelligence, that is to a certain extent empathetic, that helps us cope with our problems. I mean, the idea of Joseph Weizenbaum was to build a psychotherapist, and a psychotherapist has to show empathy. And that's really, really difficult. It's really, really tricky. And I believe this is an interesting research field, a research field I've been working on the last, as I said, more or less 10 years with my students.
Sorry, Stefan, you have two minutes to go.
Okay, thank you. 2 minutes to go. A research field that basically focuses on social intelligence. We took the idea of Karl Albrecht, who defined social intelligence as something that is based on situational awareness, authenticity, presence, clarity, and empathy. And we focus very much on this empathy. And this is some work we did that my students actually, with my supervision, did over the last more or less 5-6 years, that we published, that they wrote their master thesis about, all around this topic of how to make these kind of AI systems appear more intelligent, more socially intelligent. That includes the perception of authenticity, the perception of empathy. That also includes things like the power they have on increasing stereotypes. That's a thesis I supervised last year on non-binary voices, and what actually the binary voices, so male versus female voices, induce on us, potentially supporting certain gender stereotypes. Just to show you how difficult this is, these are kind of questionnaires that we use in order to make people rate whether something is authentic, whether something is clear, whether something is empathetic. Now, how can we, build empathy into text? How can we build empathy into voice? It's a huge topic. We are not there yet. The only thing we know is that, and that's more or less my last slide, that the future of AI, the future of our intelligent systems, are systems that are engaging, that enculturate, that act respectfully, ethics, that act context-related, that learn from experience, that use reflective language, that have strong conversational behavior, that go beyond sort of ping pong play, I want this, yeah, you get it, that have a certain personality, maybe their own personality, and that maybe move away from anthropomorphizing humans to building their own entity, being an AI for what they are, not a human being. And with this, I would like to close my talk, and I'm open for questions. Thank you so much.
Thank you very much, Stefan. Fascinating insight in sadly quite a short presentation time, but actually we do have one question for you to maybe extend your observations a bit more, and it relates to how machines can detect and kind of generate empathy, and what are the ways, like emojis, smiling faces, etc.
Yeah, so what we found is that emojis might help. I mean, there is a certain understanding that emojis try to, to a certain extent, that's the point of emojis, they convey emotions. The thing about empathy is not so easy. Why? In order to be empathetic, that would essentially mean that you put yourself into the shoes of somebody else. So if a machine is really empathetic, if it feels empathy with me, then it would need to be able to put itself into my shoes, which is impossible. We do not have machines that can do that. And I don't think we will ever have machines that can do that. There is a counter argument to this. And this counter argument is that many humans also, to a certain extent, express empathy by simulating it. It sounds, it's really a hard way to say, like a harsh thing to say. But often we empathize with somebody by just being there for this person, not really putting ourselves into the shoes of this person, but rather being there emotionally, not really being empathetic, not really trying to feel what they feel. And that might be a way around that. That might be something where I say, well, I don't need the machine to be really empathetic, but to at least to simulate empathy. And as long as we know that this is a machine and not a human being that simulates this, I believe morally that's okay. And we see this in a number of cases. There's chatbots nowadays that are used in mental health care. So where people basically do exactly what Joseph Weizenbaum proposed in 1966. They basically chat with the system, but they are aware of the fact that they chat with the system. By chatting, by putting out by getting something off their chest, they receive to a certain extent empathy. They are helped, and that's, I think, where we can go down. But really building empathetic AI, I don't think this will ever happen.
Okay, that's a good statement to end your talk on.
Thank you so much.
Thank you very much, Stefan, for your insights. Next, I would like to present Tuomas Varanka, who is a PhD researcher at the University of Oulu in Finland. And his talk will be about how machines recognize human emotion, which has a nice connection to Stefan's previous talk. So, Tuomas, the floor is yours.
Okay, thank you very much, William. So yes, exactly. This connects very well to what Stefan just said. And my group is from the machine vision side here. So it's a little bit different what Stefan is doing with text and speech, but I think there are definitely connections here. So let's get started. So when you think about emotion recognition, what you typically kind of see, or I think most people think about, is this kind of system looking at your face, facial expressions, and then giving an emotion for that. So I want to go through quickly of how this is actually done. And then I want to show a little bit of our work that we are doing in Oulu. So a typical emotion recognition system starts with a pre-processing step. And this is actually true for any face-related application like face recognition as well. So you start with the face, you detect it, and you also detect these facial landmarks. And there are tools for this that we use. I don't really go into the details of those. I don't need to. I just use those tools to get these landmarks. And after that, we can do face registration. So this is alignment of the face. We want to make sure that the face is looking straight at the camera. And then finally, we can do cropping and grayscale also if necessary. And here we have this template. So this is great. This is where we start basically doing the emotion recognition. So typically, right now, emotion recognition is doing by neural networks. So transformers are really the trendy thing nowadays. So I have a transformer here, but you can also use a convolutional network. So in this transformer network, you have an image, you put it into patches, and then you feed it through this neural network these kind of attention layers. I don't want to go too much into the details here, but these are basically matrix multiplications that are happening there. And out you get these different emotions. And typically emotions that are used are the basic 6 emotions. So angry, disgust, fear, happy, sad, and surprise. And often we also add the neutral there because it, although not necessarily an emotion, it's a common scene. The big thing with neural networks is we need a lot of data. So we want to have 100,000 samples, even 1 million for the large deep neural networks. And collecting that isn't too difficult nowadays with the internet, but annotating that data is extremely difficult and time consuming. And I want to talk about the annotation of this data a little bit later, but let me just show you some of the results this kind of a state-of-the-art network can achieve. So here, I have 4 different data sets with different results. So you can see one of the results is a 99.8% accuracy, which is incredible. It's something that doesn't happen. And typically when you get a result like this, you're kind of like, that's probably not true. It is true, but the reason it's true is because it's from a lab environment. In these data sets, the participants were asked to mimic an emotion they were shown. They weren't told to do an emotion, but they were actually shown a face that they had to mimic. And this ended up being very similar samples, even though the faces are quite different. And the next data set where the accuracy drops quite significantly is from online data. Here we have quite highly expressed faces, but there are some examples, for example, like this fear example here on the right, that's maybe like a little more ambiguous. Maybe it's from someone in like a roller coaster. You can see the hair going, and maybe the person is even happy if you kind of look at it enough. So there's this kind of ambiguity. Is it happy or fearful? And you tend to get decrease in the accuracy there. And with the final data set, it's from movies. This is where you actually get like good emotions, like very realistic emotions. And the accuracy drops quite significantly. And you can just imagine in movies, if you were watching your Harry Potter movie and you started seeing some of these faces that are very stereotypical emotions, they're very expressed, that the acting wouldn't be exactly very good. So the accuracy drops significantly there. And we get these questions. So we have post versus expressed and this suppressed emotion or this more realistic emotion. And then we have the question, are 6 basic emotions really enough? We have more emotions than just 6, right? And this ambiguity problem, as I mentioned previously with the annotation of the data. So this is a great, I think, data that study that was done by a psychologist actually. And so some participants were shown the face right here on the left side, and they were asked to think what the emotion there was. And you can see that there's quite a bit of spread. For example, on the first one, a lot of people think it's anger, but some also think it's fear, some think it's sadness, or even non-affective, or even an action. And this happens with all of these cases, especially with the third one. You can see lots of different answers. So you can just imagine when you have 1 million images that you need to label, and you have, let's say you have 7 people who are going to label the same image. You give this image to the 7 people, and then they all give you a different label for it. So this makes the annotation process very difficult. There's a lot of ambiguity. And recently there's been quite a bit of work also from our group on how to deal with this, considering these as like noisy labels and so on. But it can still be something that doesn't give optimal results. Okay, so there was this competition quite recently and about affective behavior analysis in the wild, and I think it showcases what we're trying to do right now. So rather than doing this expression classification, which is what I just talked about, so 6 or 7 different emotions, we can also do action unit detection. So action unit detection is tries to measure the movement of facial muscles. So on the picture on the right here, you can see these muscles and the movements from them. So for example, action unit number 1 is the raise of like inner eyebrows. So yeah, I can try to do that. And for example, AU4 is kind of this scowl emotion. So bringing your eyebrows together a little bit. So this is a more objective way of trying to classify these facial expressions, but you lose the side of emotion. What emotion is AU4, action unit number 4? It doesn't tell the full story for emotion there. And then the third option that is considered in this competition is the valence arousal estimation. So here, a two-dimensional space is being used rather than a discrete space of emotion. So you can think of an example like you're smiling a lot, okay, but what if you're smiling a little bit less and a little bit less? So where is the border between happy and neutral, for example? So with a continuous space, we can see this difference more clearly. Okay, so I want to turn the attention now to hidden emotions and hidden information we have. And this is work we're doing in Oulu currently. So a set of facial movements does not necessarily correspond to a specific emotion. So you can think about this as in like movies, for example, the actor is playing and they're doing a facial movement. They're trying to act, for example, that they're sad, but obviously the actor isn't feeling sad. They're just expressing it in their face. And we do this every day. We smile to seem polite to the cashier. When we say hey, we smile. But this doesn't necessarily mean that we're happy. It's just a polite way of doing things. So how could we get the true emotion of a person? And for this, we look at unconscious actions. So things you kind of just do without yourself noticing, or you do them involuntarily. A great example of this is micro gestures. With micro gestures, you may just kind of touch your shirt a little bit, maybe your nose a little bit, rub your eyebrows a little bit, or maybe cross your arms. These are different micro gestures that may give away your emotion or your intentions without you really noticing it. We can see this also with in real life. I think we also see this in crossing arms. Perhaps it's you want to be more distant, but it doesn't always mean that emotion. Sometimes you just cross your arms, for example. So this is work we're doing right now. It's very preliminary so far, but we're hoping to find connections with different micro gestures and emotions. Next up, we have microexpressions. So this is something I'm currently working on. Microexpressions are subtle, quick, and involuntary facial muscle movements. So it's something similar to micro gestures, but it's on the face. And this time they're actually very subtle and very quick. So noticing them with a human eye is very difficult. Here I have on the right, I have a few examples. These are GIFs, so they are moving, I promise you. The movement is just very subtle. The GIFs have been slowed down by 10 times so that you can see the movement. If I didn't slow them down, it would just be way too fast. And the movement you are seeing in all of these is the action unit number 14, so the dimpler, kind of this movement with the mouth. And this can, for example, I think in the first case, the person might be trying to hide happiness. It may indicate that. but we need to do further studies to really understand the connections there. The length you can see here on the left diagram. So a microexpression is typically less than a half a second, typically even about 100 milliseconds. So these are really emotions. They're so quick that you cannot really see them with your eye. But with a camera, we can do this.
Sorry, Thomas, you have 2 minutes to go.
Okay, thank you very much. Then a very interesting thing we're also doing is remote heart rate using a camera. So on the right side, you can see a GIF of this person's skin flashing, but actually what you can see is their heart rate there. So we have used we haven't. A technique has been used there, a signal processing technique has been used that can magnify the frequency band in which the heart rate is, and we can detect this heart rate change. So this is really based on, you can think about when you're, for example, embarrassed, you may get really red. So this is based on the same thing as that. And with this information, as with microexpressions, we hope to understand hidden emotions, and from the hidden information, we hope to understand emotions better, and especially mental health is one major applications we're hoping to help with that. And with this remote heart rate, we can also get the heart rate variability, which has been linked to stress estimation quite heavily. And of course, it can also be just used for remote heart rate in situations where sensors are not suitable. Okay, so that's all I had for you. Thank you very much.
That's fantastic. Thank you, Thomas. So I have one question for you from our guests. So what are some of the real life areas where emotion detection AI could be applied, for example, in business or something else?
Yeah, so I think Stefan also already talked a little bit about understanding empathy. So this is in the case of text and audio. If we really want to make smart AI and human-centered AI, emotion is one very big part of that. We need to understand the emotion side of humans. And when it comes to doing this from cameras, is the reason for that is that it's the most obvious way. Faces are where the emotion and the facial expressions are really the most obvious place we can see that. And with micro gestures and micro expressions, we're really hoping to understand deeper. And as I mentioned previously, like mental health applications is something. And that's actually where micro expressions first started. It was from a mental health patient. So there are lots of applications there.
And what would you say is the main application of this technology, in your opinion?
I think mental health is one of them, but for regular ones, also entertainment is one thing. So we can detect a person's emotion in entertainment for video games and movies, and we can adaptively also change them. But also making AI smarter. So when we have a conversational AI, it can better understand how you are feeling based on not just your speech, but also the way you are, and be more empathetic. Exactly like that. Yeah.
And then just one small question that came up as well. So do you need permission of users when you're kind of analyzing them emotionally, or how is it done in a public setting?
Yeah, exactly. This is a great question, and now GDPR is here, and there's an AI Act regularization from the EU side. So in a public space, I believe it cannot be done in a public space right now. It's similar with face recognition. It's something you cannot do in a public space unless it's for a good intent. but it gets a little bit whimsy with the details there.
Okay, that's fine. I think that's enough questions for you today. So thank you so much, Thomas, for taking the time to present your findings here.
Yeah, thank you very much.
Okay, and then we're halfway through our speakers. So next, I'd like to warmly welcome Himanshu Sani to the floor. Himanshu Sani is the AI Machine Learning Business Development Lead for Amazon Web Services. And the title of Himanshu's presentation will be Improving Student Outcomes and Enabling Rapid Modernization. So you're very welcome, Himanshu, and the floor is yours.
Thank you very much for the generous introduction and the opportunity to speak today. Hello, folks. Today, I'd like to speak to you about how Amazon Web Services is helping our customers, and particularly in the education space, which hopefully should be relevant to you all. So firstly, I wanted to touch upon where do we come from in the AI space. So my parent company, Amazon, has been doing AI research or application for the past 20 years in the field of retail. So when you go to the Amazon portal, for example, getting recommendations that if you bought this, you may be interested in buying X, Y, Z, or if you are looking at something now, this might be a cheaper alternative, which does similar things and things like that. Technology like that has found general application in many other places, surprisingly, or it comes as a surprise now, but it's been being done for the last few years now. For example, in the field of education, if we know how students interact with the system, we are better placed to suggest newer students which other courses they might be interested in, simply on the back of how users interact with that system. There's a lot of AI happening in the field of warehouses, where predictive maintenance is of big use, where we cannot afford to have even a 30-minute break in any of the operations, because as you can imagine, lots of packages which are delivered globally could be impacted. And then Alexa, my esteemed co-presenter, Professor Stefan, has already told us a fair amount about that. A lot of natural language processing goes in there, and I remember when I was in university about 20 years ago now, I was training a system for speech recognition in my Indian accent, and that was a nightmare. Despite lots of hours of training, it never got anywhere. Whereas now, I don't have to do anything. The training's happened. I speak to it, and it gets me. And a lot of that is the improvement that's happened in this field, especially because of deep learning in this particular case. And deep learning is what, I think both of my other colleagues or co-presenters also spoke to in some ways, which is one of the more important technologies, shall we say, which has had the biggest breakthroughs of late. There are others as well, but that's one of the big ones. In the field of education, where we see certain trends is, of course, the proliferation of MOOCs. You have Coursera, you have Udemy, you have many such platforms which are also offering courses where educational institutes have to compete against. But equally, all educational institutes are expected to become more prevalent online, and not just available online, but also offer things in an engaging manner for the students, and also do it in a cost-effective manner. And where we see our customers already deploying these solutions and finding a fair amount of success is if we look at it from the perspective of a student's journey, when it comes to the application process, for example, the marketing and recruitment teams within universities, making sure that they appeal to the right fits, where the students and universities, match each other and are best fit for one another. Whether it's streamlining the admissions process, making it faster, more effective, using automation and artificial or machine learning rather, or whether it's making course content available and making that course content relevant to students so that they can form their own career path in some ways based on how students have interacted with in the past and have found success, and using a lot of intelligence based on data of how systems have interact with one another. And we see many examples in the other aspects you see in front of us on the screen as well. Let me move on to some examples where some of our customers have actually found a success. So Coursera is one of our customers. And as I mentioned, we learned a lot from user experience in the retail space, where how recommendation systems could be designed. Using that technology, we've made that available to the education customers as well. Coursera being a prime example, where they have millions of users. And they were able to create a recommendation system within weeks by using a lot of the underlying platform, which is called AWS Personalized, for example. And there are also systems now in place where even when you cold start, and if you just have information about how a user is moving their mouse in the first few seconds with how they interact with the system, that also gives us information on how to start generating recommendations for them. And then, of course, as has been highlighted before as well, the more data you have, the better it gets. The more interactions you have for your own systems, the better you'll be able to make unique recommendations for your own users. Another example, which is found not just in education, but in a variety of areas, but particularly when you have students of all ages, something like this could be quite important. Where the content moderation systems today are able to give us the categorization of how safe the images are, not just a black and white answer, whether they're safe or not, but actually defining categories as well of what kind of nudity, for example, do you see, or what kind of revelation that might be there. But equally, also providing a confidence threshold of how confident the system feels that it's detected this correctly. Because at the end of the day, it's only as effective as the data that it has been fed. And as has been highlighted before, these systems are not truly intelligent, and I agree with that statement very much, that they are, firstly, why do I feel they're not truly intelligent? Is that we as humans have to frame the problems for them. We have to give them the data. We have to define, this is what you need to do. In some cases, they become better than us. They're better than playing chess. They're better at playing Go, as we've seen in some other things. But it's us who framed the problem for them. They have not come up with, at least they haven't gotten that clever yet, where they are able to form the problems for themselves. And in the same way, it's over here, we have to define what sort of, inappropriate text or inappropriate pictures we're looking for. And then what's good is that these systems are able to tell us, I can tell with such and such confidence based on past behavior and your feedback that this is what I found. And you can then define rules with human intervention to say, when the threshold is above such and such percent or 95%, I know that it never goes wrong and I'm okay with it. But if it drops below a certain threshold, then I would like that this is flagged to a human operator who would then double check and make sure that it's brought back in. There's also been a lot of demand for virtual proctoring, as you'd expect in the age of COVID that we've been living in for the last 2 years. There's been a need to conduct tests, exams virtually, and there has been a need to become more effective in being able to invigilate or monitor such tests, where you need to be able to do identity checks, for example, making sure that the person who's attending the test is the person that was meant to be, comparing them against their identity documents, for example. Also using image recognition or computer vision, as was the case with Thomas, using this similar technology, but in this case, looking for signs of cheating, for example. And then equally, besides education-related items, you also, within institutes, there's a lot of cutting-edge research going on. And we saw a couple of examples already. And that could be related to other areas, say healthcare. You may want to detect cancer, for example, or you may want to replicate what radiologists or doctors do sometimes by looking at scans and images, and very specific areas where you wish to, based on certain images that you can train them on, you're able to detect certain things. All those things can also be implemented on platforms that, say, AWS makes available, whether as a packaged service or as a data scientist where you need access to resources, a GPU or a CPU, and then you know which platform you wish to use on it. And I'll explain that or touch upon the various services or the products that AWS offers so that it becomes a bit clearer as to how someone can engage and start doing these sorts of things themselves. And one last example that I wanted to touch upon is especially, with your with Finland punching way above its weight, especially when it comes to racing and Formula One racing, and Mika Hakkinen being one of my favorite racers, I wanted to just show you an example of how we use machine learning. So as you can see over there, you're able to make accurate and real-time predictions on whether an overtake would happen in this particular instance, for example. And this is all possible because there is a lot of data that is being collected. And Formula One is one of those organizations that's always been big on data. They've been ahead of the curve when it comes to having sensors, collecting that information. And we at AWS were able to work with them to firstly help streamline, collect data at scale in a low latency manner, and then able to apply machine learning on top of it and generate predictions in real time to improve the user's experience. So a lot of progress has been made in this field of machine learning and AI. Even though I agree that we're not truly intelligent, and that sort of gives me hope that there is more to do for us to learn about how human intelligence truly is, and maybe get even better at that. Having said that, I agree with Professor Stefan that there are some things that maybe we shouldn't aim to, or we may not want to do when it comes to aspects of emotion and things like that. The core part of our brain, the lizard brain, so to say, that's what makes us more human, maybe. Whereas what AI and ML is focusing on these days is more what the neocortex does, and how to do pattern matching and things like that a bit better. Now I'd like to
Sorry, Himanshu, you got about 2 minutes left.
Okay, I'll move very quickly to now the technology aspect of it. So AWS has a broad, we claim it is the broadest set of machine learning capabilities. And we are looking at a multi-layer cake, or a 3-layer cake in particular, where at the bottom, you've got support for the frameworks, a wide range of CPUs, GPUs, whether it's from NVIDIA, from Intel, AMD, anyone that we believe our customers could benefit from, including our own chips, we will make that available to you. The layer above that is more catered towards data scientists, primarily, where you have an IDE called SageMaker, which allows you to build, train, deploy models at scale, and also debug them, and now look at explainability as well. And then there's also things like ground truth, where you can do data labeling, which is a point that Thomas made earlier about that's a challenge of how to, when you have lots of data, you actually want to label it as well. And then the layer above that is where we help primarily software engineers who understand software, but are new to machine learning, and they want to embed machine learning in their software directly by making API calls, for example, doing computer vision, or using image recognition to identify certain objects, like we saw virtual proctoring, and you want to embed it into another software without having to build the models yourselves. There are many services that are built, from personalized to speech, where we do translate into multiple languages. We do speech to text, text to speech. We do NLP, or natural language processing, as was mentioned earlier, intelligent search. There is a whole variety of things that you can do over there. And I will leave you with, if you wish to get started or know more about how to learn machine learning or just get more advanced at it, there are many options. SageMaker Canvas is one word I'll leave you with. This is something you can look up. This is more for business analysts who have a lot of data, but they would like to predict things, but not necessarily build models themselves. And then there's a free utility where you don't necessarily need an AWS account, but just your email address, and go to Amazon SageMaker Studio Lab, and you can try for free on how you want to build your models yourselves, train them, and try them out. And many people use Python, and that's what this one focuses on. You can also use R, but those are the two that you primarily find support for. And there are, of course, the services like Comprehend for NLP as well, the third layer that I mentioned. You could try using those as well on top. And the final statement is on Deep Racer. If you're interested in training your own car and want to run it around a track in the fastest way possible using self-driving in an easy way, I don't want to make it sound daunting. There's an online forum and a community race called Deep Racer. And if you like, you can also participate in a physical race where we have a track set up and a car available, where once your models are ready, you can throw your models at us and you can see the car go and see how you do it in comparison to others. So there's many ways for you to get started on machine learning if you're interested. That's me.
Thank you very much, Himanshu, for your presentation. I have one question from a colleague from Hagahelia, from Porvo, Darren. And Darren, I apologize, Trofmizjuk, I can't pronounce your second name, but Darren is from Hagahelia Porvo campus, and he's just completed his AWS Cloud Practitioner certification and now working on the AWS ML certificate. And his question is, how well do first or second year degree students cope with learning the AWS machine learning content?
Could you repeat the first bit? First or second year student, was it? Did they say?
No, it's one of our lecturers from our Porvo campus here in Hagahelia, and he has just completed his AWS Cloud Practitioner certification. And his question is, how well do first or second year students cope with learning the AWS ML learning content?
Yeah, okay. I mean, ML, if I think you've already done the practitioner, which is a good one to start with. Quite often people also do the associate level. I would say that gives you a kind of a good understanding of the AWS ecosystem and how you would interact with other services alongside machine learning. However, if you're interested directly in the machine learning track, if you have some exposure already, I would say a few months of playing around with Python generally and trying out a few algorithms, you are in a place where you can start, I would say, preparing for the machine learning certification. Going straight for the certification without sort of exposure to these technologies could be a challenge. I probably would discourage against that. But with some exposure, some experience, yes, you could skip some of the other levels. And if you're keen on machine learning itself, you could definitely try that.
Great, thank you for the answer. And I have one further question for you. Does Amazon provide also free or open source machine learning resources, or are they all priced?
No, there are many free resources as well. I could probably send you some links. I mean, if you go on the website also, there is a training and certification page that you can see, and there are quite a few free resources over there. There are many videos on the Twitch channel. There's one called SageMaker Fridays, for example, where you can see how the products work and get started with that as well.
That's fantastic. Thank you so much, Himanshu, for taking the time to speak with us today.
No problem. My pleasure.
Okay. And okay, next up, we have our final speaker, who is our own Hagahelian, Heli Kortesalmi, and she's a senior lecturer here. And the topic of her presentation will be applying AI and RPA solutions in small companies accounting. So very welcome to have you here, Heli, and the floor is yours. And the
Thank
dog.
you so much, William. Yeah, and my dog has been silent the whole time, and now he started to bark.
Of course.
Yeah. But yeah, great to be here, and I'm going to tell you about a project we're having here at Haga Helia. More maybe about RPA, robotic process automatization, which I mean like rule-based automatization. And I'm an accounting teacher, and besides teaching, I work for a few years for this project, Center of Intelligence Process Automation for SMEs, where we are targeting to help SMEs, which means here in Finland, companies employing less than 250 employees, in their digitalization and in accounting, or then trials of RPA and AI. And we focus on accounting because the people working in this project, we are accounting and IT specialists. And also we see that automatization in financial processes has served as a gateway to wider digital transformation. And I'm going to tell you briefly about our project, and then I have a really practical case example for you, what we have done. The project is funded by the European Social Fund, so a small commercial for them. You must have seen this sort of articles or titles on articles like Technology Magazine says 9 out of 10 businesses are implementing RPA by 2020, so last year, or Deloitte says that next year every company has applied or used RPA. About artificial intelligence, McKinsey says this year that 57% of companies are testing it already. And then again, Deloitte's RPA survey, last year, 78% of the respondents had started their RPA trials. So looks great. We are pretty automated, but I wonder if this is true. So our question here is, what about the SMEs? What about the small and medium-sized enterprises, which we have quite many, and they are significant companies as well. If we take, and of course I take Finland as my example, in Finland we have nearly 300,000 companies, out of which 99.8% are SMEs. And then if I scale them into micro-sized, which is less than 10, employing less than 10 employees, we have 93% of those, which is this yellow area, and then the small ones. So actually in Finland, about these statistics that I just show you, in Finland, which is a tiny country, I agree, we have 682 big companies. And then we have this 200,091 and something companies which are considered as SMEs. And these companies bring us over 40% of our GDP, so they are significant, but are they able to follow in this in the competition? Are they competitive enough? Are they able to apply these modern technical solutions and be efficient in their operations? That's my question. In our project, we did, with the help of some of our students in Haga Helia, we did some surveys and interviews about how companies are using RPA, and this research is ongoing. But we targeted our first surveys to accounting service providers and real estate management firms. There was a small sample, and according to the responses, 51% of the accounting firms said that they had done some RPA trials. We also asked about AI, but it was so minimal that there's kind of nothing to report about. 51% of the real estate management firms had some RPA in use. And quite a few of our respondents were still providing paper accounting services, meaning that the entrepreneurs collect paper documents of their accounting transactions, and then once a month they bring them to the accountant, to the accounting firm, and then type in the numbers in the papers into the accounting system. This also slightly worries me because in Finland we have great, really automated cloud-based accounting software available, which are based on like e-invoicing. E-invoicing is widely used here in Finland. So everything is really automated, but these have not been taken into use yet. And that's one interest area of our project. But getting back to the RPA, the reasons that our respondents, why they don't have RPA is that they don't have time to do it. Well, kind of funny because it might save your time when you automate your routine tasks. Of course, understandable lack of money. Some of the accounting firms said that their customers don't want any automated accounting. They like paper. I wonder if they wash their clothes by hand, or did they buy washing machines? And then also some of the accounting firms said that they don't want to. But the real estate management firms said that they don't have skills to do it. So this was brought up at their side a bit more. And yeah, we chose these two industries in the beginning because they are, all of them, even they are in the same industry, they work in a pretty similar manner. And in Finland, in both of these industries, the markets are pretty polarized. So there are either big chains which are acquiring smaller companies, or then there are these micro-sized accounting firms or real estate management firms which employ 1 to 2 employees. And I don't know what is the future for the small ones again. If I'm thinking about RPA and AI for small companies in their accounting and finance processes, I guess these are the solutions for them. First of all, they could be using these modern cloud-based accounting information systems where the AI or the robotics is inbuilt. For example, there could be machine learning-based handling of invoices, so based on the historical actions on invoices and which accounts has been used and which cost centers has been used, AI or RPA can suggest or even make the accounting postings pretty correctly. Also, if there are some PDF documents, OCR can be used for reading the paper or the PDF documents and of invoices. So I think that the 51% who responded that they have used AI or RPA, they use these modern systems that have the inbuilt artificial intelligence or RPA solutions. Second possibility is to generate or create own solutions. So then you like code your robot, you analyze the process, and then you outsource it, that somebody makes it for you, the automatization. Of course, it costs quite a lot. Even a basic automatization for a small company, it might be like 10,000 euros, so it's expensive. Also, you need to have the skills and the time, which our companies were missing. And certainly you have to pay the robots some salary, kind of. So there are those fees that you annually have to pay after even the development of the automatization. There, the solution could be these open source, for example, Python-based solutions, where then they don't cost that much. And also I see that the no-code solutions, meaning a citizen developer level RPA like UiPath Studio X product or Microsoft's Power Automate might be quite handy because those are things that even I, who cannot code, I have helped myself with the automatization of my work. But where we are focusing here in our project are these multipliable AI and RPA solutions. The term isn't maybe that common, but I couldn't find a better one. But basically, if we have similar kind of industries, we could build an automatization which could serve several companies on that industry. We just have to find that what all of the companies do, and then we build the automatization, share the cost, and basically rent a robot, like a robot as a service, this RaaS term is. We found one company, one accounting service provider here in Finland who actually did this for invoice handling, but we are looking for these solutions, and my example is going to be about those. So that's the focus in our project here. So we wanted to find that what is the task that that would serve, that several companies are doing. They find it a bit difficult, but we could be automated. It's simple and rule-based. And we are focusing now first with the accounting service providers. We have some years left with the project, so we can take other industries as well. We interviewed entrepreneurs and some specialists, and then we decided to take this case of new payment methods. So here's some lovely T accounts, how traditionally the accountants would book a car, for example, the customer payments for a company. It could be cash, it could be bank, and bank account transactions are totally automated in Finland already, even in a bit older accounting systems, and then of course accounts receivables. But today, there are web payments and international providers. So this is what the accountant is going to see in practice. There might be even more service providers. So how to automate the accounting transactions from these. And they might have an integration with an American accounting software and system, but definitely not with the Finnish one, which are really popular here. So we want to, even this is automated and handy for the customers, it is pretty manual for an accountant to do. So this is our case, and as always in an automatization project, first you document the process. So in simple, the process is that first the accountant runs a report from a selected, from all of these systems that the customer uses. For example, let's say it's PayPal. The accountant needs to log in with the customer-related user IDs. Accountant might have several customers, so then you need a lot of user IDs. Then you run the transaction reports to see what kind of payments there has been, and then you have to run reconciliation report. And definitely it's important to know that how big is the volume, how long time it takes to run these reports, and how many customers you have, and so on, to analyze whether it's a good idea to automate it. Next, the accountant processes the report. So they are in Excel format typically, but you have to modify it so you can get the information needed for your accounting. Often the payments are done in different currencies, so you have to find the exchange rate, convert into euros. You have to decide which accounts to use in accounting, and also the VAT handling is important. And finally, you do the accounting booking. So you log into the accounting system, create the accounting document, and maybe if you have created a nice Excel template, you can copy paste the information into your accounting system. And finally, then reconcile everything. Looks like this all could be automated because it looks pretty simple.
Hi, Heli,
yeah.
Sorry to interrupt you. You got about 2 minutes to go.
Super, thanks. So, the companies that we discussed about this, they were thinking whether they should automate the whole process or just some tasks. They faced that it is a challenge to logging into these systems, but because they might have like this two-way verification, which is really good and safe, but difficult for a robot. And what we then found out, of course, like always in this sort of automatization processes or any process development, that the process need to be unified. Each accountant and different companies did it differently. So our solution is that for running the reports, we can do a proof of concept, and that's what we're going to do here and test that it's doable. Before we automate the whole process, we suggest for our customer companies that they need to unify the process so all the accountants are doing the same, all the customers are using in a similar manner the system that we tested, and so on. And for the accounting booking part, actually the modern accounting system, there is also already a solution for automated software. For the Excel modification, before everything is unified and before we have the robot in place, perhaps it's a computer-based robot, we decided to recommend a non-coding solution. So the accountant can himself make a robot which edits the Excel. And now in our project, we're looking for more of these tasks to recognize that what kind of other unified or multipliable automatizations we could get and try that could serve several companies. But thank you. This is all. I hope you enjoyed accounting for a while. Any questions?
Thank you very much, Heli. That was an interesting perspective on the implications of AI. So thank you very much. Actually, I have one question for you, if you don't mind. Do you think that SMEs need IT skills for implementing RPA, or can they buy it as a service from accounting firms?
Yeah, definitely. I think that is what the accounting firms can provide. And I've seen a few use cases where they were really wondering in the beginning that are their IT skills sufficient? But that was definitely not an issue. These modern accounting software are really good and easy to use. And then these renting a robot for the time that you need, I think it's so convenient to use and buy the skills outsourced. So I wouldn't say that the IT is needed. The entrepreneur can focus on the thing that he or she can do.
So easier to outsource. Okay. Yeah, that's great. Thank you very much, Heli. And that actually concludes our main presentations for today for our four speakers. We still have some time left today for some questions, for an open discussion, for some questions from the floor. And I have one question that I'll pose to our four expert speakers, and let's see who wants to take the question. So, is applying AI to business processes more IT related challenges, like technical, or business development challenges? For example, attitude, readiness, how to do something new. How could we boost the adoption of AI related to business processes? So who would like to take that? Anybody, any opinions on that point of view?
I could go first.
Yes, please. Thank you, Himanshu.
Yeah, I believe what I notice with AI, how it's improved RPA processes, is that it allows things to be more ready to deal with changes. With RPA, you, of course, code for a certain set of things, and then new changes come along, and there is another process involved. Whereas if we identify the right problems, which are AI suitable, then the learning curve is much smaller. Like an example is there's a company in Sweden which does frozen pizzas. Dafcards, if I'm pronouncing it correctly. But they set up a process to inspect whether a pizza looks correct or not at the end of it. And you can imagine they come up with new pizzas with new toppings, and that changes the process. With computer vision, you can very easily train with a few images of this is how good looks like, and your other process stays exactly the same, and you're fine. Whereas in other technologies, it's a lot slower.
Okay, fantastic point of view. Anybody, any of other speakers want to add to that?
Well, I think you get a good point, Himanshu. I think in the beginning, at least with the smaller companies that I have been working with, you first have to change the attitude and the mindset, and then perhaps next IT skills will be relevant.
Yeah, I would actually add to this that I think one of the biggest challenges that we face is that companies still see artificial intelligence as this big black box that is doing something completely weird, and they don't really understand what is inside. And so to offer training to business people on the basics of artificial intelligence, what artificial intelligence can and cannot do, I think would open up the space and push more businesses to actually identify use cases for AI. Many of them, they don't even see any use cases for AI, but because they don't understand what AI can actually do. I think that's the way I see it.
Yeah, I agree. When we asked about that, what they want to learn in our trainings, it was like what the others do. That's like most interesting thing. Get the use cases.
Okay, thank you very much. I have another question from one of our followers, Margarita Romero, who comments that it's actually quite an interesting webinar we're having today. And she'd like to know, have you developed the taxonomy of micro gestures? So it's one of the interesting challenges that they are facing in tinkering activities. Tinkering activities being the analysis of creating creative problem solving through behavioral observable gestures, etc. Do you have any comments on that one?
So I guess that question is for me probably.
I think it is a little bit, yeah.
I have to admit that it's work that my colleagues have done, so I haven't really looked too much into it. But I have heard some discussion that there are definitely hierarchies there that are being done, and with gestures that are similar to each other. But that's the only thing I can give you, unfortunately.
That's okay. I guess it's quite a specific question. Any other comments on it, or I have plenty of questions. So, okay. Well, I have one from Studio de Mantolio, and this is, I think, quite a big one. Does this AI eliminate human elements entirely? Anybody want to take that big one? I'm going to say Stefan because you're the one who's laughing at the question, so I'm going to put you on the spot.
Whenever I give a talk about AI, I'm always asked the same question: does AI take over my job? Does AI take over all the things I do? And that's why I basically do not want the AI to come. And my answer is, well, certain parts will be taken over. There is jobs that a machine can simply do better than humans. Everything where there's mathematics involved, statistics, calculations. I mean, these are things that we can train machines to do for us, to do them better. And I would argue even more objective. The tricky parts, I mean, in these kind of things, I mean, I think the future of AI is self-driving cars. The future of AI is monotonous tasks being done by a machine. So as soon as we can explain this to a machine, the machine can do it and can do it better than we do. The bigger question is then, what do we do? And there's jobs and tasks that I believe that we are far away from machines taking over. Everything that is connected to human abilities like emotions, empathy, but also creativity. It's a big thing, you know, creativity. IBM tries to sort of solve this creativity puzzle, making machines more creative. And then again, it comes down to the question, what is creativity and how can you make something creative, and who judges what is creative and so on. But I think there's enough to do left for us. And maybe at some point we have to ask ourselves the question, is it really what mankind or human society has to do is, you know, work all day long? Maybe we're actually good at some of those jobs are taken over by machines, and we have some more time to do inspiring things and interesting things, and things that make us happy, instead of standing at the conveyor belt all day long for 8 hours, moving things around. A robot can do this better, actually, without back pain.
Thank you, Stefan. Anybody else want to take that? Himanshu?
Yeah, sure. I'll echo the same point as Stefan made. It's I see that as any other technology revolution, which affects some areas and then brings improvements in some others. And it's one of those which right now is at that cusp where I feel that it's made some headway in the last 20 years where people had given up on it. And then with deep learning, they see that it's bringing improvements. And in narrow areas, we're very far from general intelligence. It's able to do some things better than humans and take away some of the monotonous tasks. I think where the opportunities lie is where we try and make it truly intelligent. If you think about futuristic scenarios, as Elon Musk would say, we'd like to put people on Mars. Now, if you need a robot that goes on Mars and able to do things, that prepares things for humans and is able to cleverly understand what the requirements are and adapt, like how we do, we are far away from that. Actually, we are not even thinking on those lines, I feel. And once those things open up, and as we are evolving and we have, we're getting energy from the sun and other sources, and we are moving to a world, hopefully, of abundance rather than scarcity, as how we like to think of things. This is a technology which will open up some different avenues and make things possibly much richer. There are risks, yes, but it's a societal risk. And like anything else, it's something that can be managed. I don't see AI personally as an existential risk. It is something we could harness like any other technology, but we need to be careful. Yes.
Thank you for your insight. Heli and Thomas, any last requests before we wrap up for today? Any last points of view on this?
Well, if I'm thinking about my own work, sometimes working overtime and so on, so I would rather have AI or RPA or robot doing some of my keying in grades from one system to another one. So the manual work, I really wouldn't miss that. And I think the accountants as well, that there is a lot of manual work, but they have a lot of knowledge that they can share and advise on taxing and which expenses you can include into accounting. So I do agree that people could focus on like more usable work, if you say so.
Thank you, Heli. And Thomas, anything you'd like to add to that topic? Or?
I think I definitely agree with a lot of the people's statements here. And from my perspective, emotion, I would like to just add that, if we want to go for really intelligent systems, we need to also understand the emotion. It's just human is not just a logical machine. There is emotion, and this empathy that was also talked about there is very important. So I think there is still a lot of work to do until we get there. But that's all for me. Thank you.
It sounds like an extremely interesting journey. And after hearing from the four speakers today, the different perspectives, I feel like we're at the cusp of something, but there's still a lot of learning and a lot of researching and analysis to be done. So, but with that, I would like to say thank you to all our speakers. We've come to the end of the webinar time today. It's been an absolute pleasure to hear from you. It's been an extremely interesting webinar from our four speakers. Thank you much for coming, Stefan and Thomas, Himanshu and Heli. It's been a pleasure to have you here. Before I wrap up, I'd just like to say thank you also to the Compass team for facilitating this webinar. And if you want to catch up on any future webinars coming up under Compass, please, you can stay tuned by following Ulysses on Twitter or LinkedIn or ulysses.eu for any upcoming updates. Other than that, I wish you all a lovely afternoon and a lovely spring. And that's the end of the webinar. So thank you very much. And we'll see you later. Thank you. Bye-bye.
Thank you.